Hey guys, welcome back to the free Unity course in which we learn about Unity and we also learn about C# a little bit. So, last time we left, we actually iterate through our array using a for loop, a double for loop in this case, but we never really add any visual to, just have a look at this data. So today we're going to learn how to spawn objects. We're going to be learning one of the way to spawn an object, how to spawn primitives, and there's also going to be another way we learn in the same episode actually when we spawn our apple. So I'm going to start with the very first one. Just have a look at this line of code right here, GameObject.createPrimitive, and then ask you what type of primitive you want to create. Now, you don't really see what I'm seeing right here, but it tells you can create a capsule, a cube, a cylinder, a plane, a quad, or a sphere. In our case, we're going to be spawning a cube. So with that simple line of code, I should actually be able to just randomly spawn a cube in the middle of my world. And if we have a look here, here is a cube. So that is what I plan on using to actually put, say, right here or on the other line. That's going to be my trail, basically. Now, here's what I'm going to do in this case. Since we want our trail to stay for a little bit longer, what I'm going to do here is say snake score is going to be equal to 3 at the beginning. So we should have a length of 3 in the first array. Right. So every time we move, we want to be spawning a new one of those all the time, and we also want to be positioning it at the right place. Right now it was positioned at 0, 0, 0, which is obviously not going to work. So here is what we are going to be doing. We're going to be using that line of code, and we're going to be putting it every time we move, because every time we move we create a new cube. And then later on, every time we move, we're also going to be removing one cube, the last one basically. If we just head down, I have this in my clipboard, so Control X on that. If we just head down to where we move, which is right here, we're going to say GameObject.createPrimitive, and now we have to move this object. And I know I'm going to be skipping over like few important things, but we're going to come back to them really soon. But here's how I am going to actually keep track of what cube I actually get out of this. Basically, this is a function, and functions sometimes they can return you value. Now, we never really saw that before because every function we create has this keyword in front of them, which means void means nothing. Basically, you always return nothing. So private void update means you're not getting a return value back out of that. And like I said, this is something we're going to be covering, but right now just bear with me. Check this out. We're actually allowed to do this thing. So we declare a new game object we call geo, and then when we create one using that function, there's also a return value. In this case, the return value would be the cube that we create. So geo would be equal to the cube we just create right now on this frame. On the line beforehand, we create a cube, and geo is equal to that. So with this, we can say geo.transform dot position and then move it somewhere where we need it. So where exactly would be the right place to move this cube? Let's actually try moving it to snake X and snake Y. Now, to move it here, we have to store it inside of a vector3. And if you guys remember, we have to do that because dot position is actually a vector3. So we have to create a vector3 to position our cube. And here's how we're going to be doing it. We are going to be declaring a new vector3, and inside of the parentheses, it takes in it has 3 overloads. The first one is empty. You can leave it like that. It's going to create a new vector3, and that value is going to be equal to 0, 0, 0. Now the second overload is x and y. So you can give it a x and also a y value, and it's going to create you a vector3 with that. So it's basically going to add a z value of 0. Or the third one, it says x, y, and z. So you can give it a normal x, normal y, normal z, and it's just going to create you a vector out of that. So we're going to go ahead and just type in snake x, snake y, and just to be sure, we're going to be typing 0 here for the z. Okay, let's run this code, see if we actually get any problem. We end up having something, but obviously this is definitely not what we want here. So with this value, with 0, 4, 0, we actually get something that doesn't look too bad, but there's definitely some errors. So let's have a look at what exactly those errors are. Right now, if you can tell, on the very first frame, we don't create anything here, and that is something that is not going to work. So basically, we should have something being left behind us. But we also create a new cube that is stacked on top of our head, which is definitely not something we want. So we just have to reverse the order in which we create our cube, so our cube goes back to the spot we were, and not where we're going. So I'm going to be actually moving my code a little bit. So these line of code, let's move them to somewhere where they make a little bit more sense. So if we just go before we actually add up our direction, we can be creating our trail here. As simple as that. Now obviously there's going to be some cases where this is not a good practice, and that is when we actually hit the N here. Let me just show you. So when we end up losing, we end up stacking a lot of cubes here, and they just keep going. However, our snake is actually still, in the bounds. He's still right here. That's our snake, but we just keep creating new cubes all the way there. So definitely there is some checks to do. There is definitely some error checks to do. But right now we're actually going to disregard this error. We're going to leave it here because later on we are going to implement a logic that says if we lose once, let's not even update that whole code. Let's not even run that code. So if we just lose once, then we're not going to be spawning stuff. We're not going to be testing again. We're going to be saving memory, and we're also going to avoid this bug. But right now we know that this actually works. So we actually create a new object. We position it at the right place. Now we just need to remove it. And now that is a very tricky part, because I plan on doing the delete right here. When we do a minus on where you are, say you were on the 1, you go to 0, this is where I actually want to delete. But now which one do I delete? Which is going to be quite hard to actually tell. Let's start by actually putting brackets on that and start writing down our condition. So if grade at the index I and j is now equal to 0, because if it was at 1, we do minus, and then it goes to 0, that means we have to destroy something, a block basically. But how do we know which one it is? Because when a new frame appears, this thing is out of memory. We don't really know what this is anymore. So there is few things we could actually do to find which object is the right one. We could be renaming our object, giving them like a very specific name with their position, and then we find them using their name. We can be looking them up using their position. We could do something like that, so we can find an object based on its position. Now the best way to actually go about this would be to use a list, because you can actually push and pop out of the list, but we haven't seen list just yet, so we're gonna keep it, I would say simple, but it's still gonna be a little bit complicated. We're going to be changing the name of the object when we create it, and then we're going to be accessing that name. Let me just show you exactly how we're going to go about doing this. So when we create a new cube, we also move it to a known position. We already know where this cube is going. Now what I'm going to do here is actually change the name of that game object by doing geo, so our game object, our cube we just created, dot its name, so we're accessing its name, and we're going to set it to snakex to string. It's actually a function that is going to convert our int into a string. So if our int is 1, it's gonna actually write it in a string value basically. So we don't actually consider this as an integer anymore. Now it's a string. Then since we have a string right here, we can actually add it up with another string. So let's do snake y dot toString. And if we just run this, have a look in the game, what kind of result we get, this is what we get. So 0, 4, 1, 4, 2, 4, 3, 4, and this is pretty much just telling you where in the array this is. And also be careful, because you can also go in the -1, so -1, but this is not going to happen once we have our def check. So if we're dead, then we're not doing the update. But basically, using this line, we're now able to know, if we just take the name of the object, we're able to know where exactly it's positioned. So I'm going to be using the same exact logic to actually fetch it from the other side here when we're trying to delete. So let's do something like game object find, and the object we're trying to find is I toString plus j toString. Now again, this is a function, like I mentioned earlier, this is a function that returns a value. And this is going to return you a game object. We can call it toDestroy. And now that game object to destroy is going to be equal to the matching name there is, if of course there is. Now what I'm going to do next is actually invoke unity destroy function that takes care of just getting rid of an object. We're going to do destroy, as simple as that, and in the parentheses it's going to be taking what exactly you're trying to destroy. In this case, we're trying to destroy, which is our game object, so we're trying to get rid of that game object. Now we are going to hit a lot of problems. Let's have a look at those problems. And we don't actually have any problems. Okay, so I was expecting to have some problem in terms of not being able to find the object, and I didn't get a problem. So I'll just make the check here because I believe that eventually we might hit it. Just have a look at this. So basically, if to destroy is not equal to null, if it is not equal to null, then we're gonna go ahead and just destroy it. This is a safety check, because in case to destroy is actually null, in case it was not able to find a name, a game object with that name, then to destroy would be equal to null, and it would try to destroy something that is null. In that case, it would also crash the game. So now this is a safety check to make sure that the game is not actually going to crash. Let's actually play our game. It actually it's starting to take shape here. So that's definitely not too bad. As you can tell, our snake score is of 3, and we always have 3 snakes, or 3 cube in that case, snake being our head, and then now 52 would be something 5 in X and also 2 in Y. Let's quickly do something so we don't get confused too much. I am going to create another cube, call it wall X or wall minus X, and just put it on the left side here. So -1 in Y, scale it up by 5 in Y. Or is that going to be enough? Let's use actually 10, so that's actually 10, my bad. And also put that 5 here. So we actually have some bounds going on. Same thing for the other side, so wall X, you want to be putting that at 11. Or do you want to be putting that at 11 or 10? Let's leave it on 11. Now another wall, in this case, this is going to be wall Y. You want to be changing the scale in X to 10. And then you want to be changing the position in X to 5. We just put it up here, that should be on 10 or 11. I'm going to be using 11 again. And finally, wall minus Y. Let's actually test this out in the game if the wall actually makes sense. So definitely some error going on here. It should be a little bit lower than that. So here it is, those are the actual good values. So -1 here, 10 there, 10 there, and -1 here. You might want to be making this a little bit bigger in this case. Now of course, this would require actual modeling, actual effort, but I am nowhere an artist, and right now we're learning how to code, so one thing at a time, and might as well just put that on 12, make it look good a little bit more, maybe even 4.5, you know, just play around that until we get something that is satisfying. Now all those walls should actually be fine. I'm also going to be moving my camera so I can have a look at this thing while I'm playing it. That would be cool. And let's see if we're able to play on all the sides. So I'm going to be following the sides, see if we crash. Everything seems to be fine just now. Now remember, we're constantly creating new cubes and also deleting those cubes. Okay, so now let's try one step further. So I'm going to go until here, it crashes, so that's fine. And also, just for testing purpose, I'm going to be boosting the speed here. I'm going to be using some MLG skill to play my snake game. Now let's crash into the wall. Oh. And we are able to crash here on this side as well. Let's go down. Also crashing here. And we should also be able to crash on this side. Yep, so we're crashing on all the sides. Now let's try the artist part here. I'm going to be putting my snake score on, say, 5. Let's put back the speed to, say, 0.35, why not? And we're going to try to crash in ourselves. So let's go ahead and just have the full length. Now let's do a 360 loop. Actually, I went down, so I did crash on myself. Let's try that again. Up, left, and down, and I was crashing in myself. Now, as you can tell, we stopped moving the actual snake because we lost. The snake is still at the losing position, still right here. And what we're going to do at this point is we're going to make sure we don't update anymore once we lose. So it's going to be fairly simple. We're going to be keeping track of that using a boolean. So bool has lost is going to be equal to false by default. And then if we lose, we are going to say has lost is equal to true. Same thing here, we do lose if we go here as well. And what else? Do we have any other losing condition? I don't think we do. Okay, so now next thing that is going to happen is at the very beginning of our update, we are going to say if we have lost, so if has lost, just like that, we're going to hit the return statement that we mentioned in the last episode. So if you guys remember, the return statement would just end our function right here. So basically, if we have lost, it's going to go up here, do a if has lost, that's true, hit return, and just disregard the whole function. It's just going to go back and keep on doing what it has to do. Then on the next frame, it's going to say, have you lost? Yep, you still have lost. So it's going to return and just disregard this whole thing. Now let's give it a try, see if we still have this really messy update. So we face the wall, we don't even delete, we just lose like that, and it just stays there. Our game isn't frozen, anything, other update loop would run, but the update loop of our snake is pretty much stopped. So this is what happens when we do lose. Now let's try colliding with ourselves again. And we have lost right here. So guys, that is pretty much where I'm going to end today's episode. We're starting to have something that has a nice shape. In the next one, we're going to be spawning the apple using the instantiate and also prefab. We have to look at prefab. And yeah, so I hope you guys enjoy. I hope you learned something. And if you did, please leave me a like on the video. Really appreciate that. Check out the Patreon page. Check out the Facebook page. Check out all the stuff in the description that keeps me going. And thank you so much for watching once more. And I'll see you in the next one. Cheers.